Hello students, now we are going to see the first question in exercise 9.7. Okay, so let us write what is the given. So given is integral 0 to infinity x power 5 e power minus 3x into dx. Okay, so here the formula is, okay, we know that the formula here is integral 0 to infinity e power minus ax x power n into dx, that is equal to n factorial divided by a power n plus 1. Okay, this is the formula. So I am going to use this formula for this given integration. So just compare these two integration. So here e power minus ax, and here what is for a, e power minus 3x. So a will be equal to 3. Okay, and what is the value of n? N will be equal to 5. Okay, so n is x power n. Okay, so n is equal to 5. So therefore integral 0 to infinity x power 5 e power minus 3x, which is equal to, so by using this formula you will be having 5 factorial divided by a is 3, so 3 power 5 plus 1. Okay, so it is equal to 5 factorial divided by 3 power 6. So this is the answer for the first subdivision of the first problem. And now we are going to do the second subdivision. So in that second subdivision, let us write the given integration. So it is integral 0 to pi by 2 e power minus tan x divided by cos power 6x into dx. Okay, so this integration can be written as integral 0 to pi by 2, what is 1 by cos, that is secant. So secant power 6x into e power minus tan x into dx. Okay, and then now I am going to split that secant power 6x like secant power 4x into secant square x, that I am going to write with this dx. Okay, so secant square x into dx. Okay, so I am going to use the substitution method, so that's why I am doing all these. So which is equal to integral 0 to pi by 2. This secant power 4 can be written as secant square x the whole square e power minus tan x into secant square x into dx. What is the formula for secant square x? I am going to use that formula, that is 1 plus tan square x the whole square, okay, into e power minus tan x into secant square x into dx. Okay, so now I am going to use the substitution method. So how I am going to use this? I am going to write t is equal to tan x. Okay, so let t is equal to tan x. What is dt? dt is equal to, when you differentiate this tan x, what you will get? Secant square x into dx. Okay, so now you have to apply the limit. So the limit for x is 0, upper limit is pi by 2. So for t will be, substitute this 0 in this equation. So tan 0 is 0, and then if you put x is equal to pi by 2, it is tan pi by 2. Tan pi by 2 is infinity, so t is equal to infinity. Okay, so now we are going to substitute everything in this equation. So that is, let us write the given integral 0 to pi by 2 e power minus tan x divided by cos power 6x into dx. This is our left hand side, and on the right hand side integral 0 to pi by 2. Okay, so integral 0 to, for pi by 2 we are having infinity, so you put infinity. Okay, and then 1 plus tan x is t, so 1 plus t square. 1 plus t square the whole square, and then e power minus t, e power minus t, and then for this secant square x dx we can substitute dt. Okay, so that's why I put secant square x there. Okay, so which is equal to integral 0 to infinity. If you expand this, you will be getting 1 plus 2t square plus t power 4 into e power minus t dt. Okay, which is equal to integral 0 to infinity. So now we'll multiply this one by one. So if you multiplying e power minus t into dt plus integral 0 to infinity 2t square e power minus t into dt plus integral 0 to infinity t power 4 e power minus t into dt. Okay, so I'm just multiplying this e power minus t with all these terms. So now if you integrate e power minus t, it will be what? E power minus t divided by minus 1, and the limit is 0 to infinity, plus 2 is constant. We'll take this outside, and we know that formula, no? So we are using that formula, that is integral 0 to infinity x power n e power minus a x into dx, that is equal to n factorial divided by a power n plus 1, the general form, no? So we are using this. So n is equal to 2 here, a is equal to 1. So 2 factorial divided by 1 power n is 2, so 2 plus 1. Okay, for this, and here the same formula we are using here. So this will be n is equal to 4. Okay, so 4 factorial divided by a is again 1. Okay, you have to refer e power minus ax. So minus is there, t is there, so a is 1. So 1 power 4 plus 1. Okay, so we need to simplify this. So it is e power minus infinity, and then divided by minus 1, and then e power 0. Okay, so you are getting e power 0 minus e power 0 divided by minus 1. Okay, plus 2 into 1 power anything is 1, so denominator will be 1. 2 factorial is 2, plus here 1 power anything is 1. 4 factorial is 24. Okay, 4 factorial is 24. Here e power minus infinity is 0, so the first term will be 0, and the second term will be minus into minus is plus, so plus e power 0 is 1. Okay, 1 plus 2 2s are 4 plus 24. So the answer is 29. So 29 is the answer for the second subdivision. Clear? Okay.